On the for roof, we have to calculate again the local force coefficient. What we have calculated for the flat surface or what the same procedure we have to follow to get the for force coefficient for the roof. I'll just open the code. So these are the force coefficient for pitched roofs for rectangular cladded building. So there are some other slope also for which the force coefficients are given. That is this for monoslope. Then for we have so this for the arch shape, dome shape structure for which we can calculate the wind load as per this criteria. So we'll go through the wind load calculation for the pitch roof when we have shade or any warehouse that will have a slope on the both the direction when the width is more. So we'll consider this pitch roof. So for this, we have to calculate first the height to width ratio, and we have to check in which category we are falling. So in our case, it is so h by w or h height by width ratio is 0.75. So h by w is 0.75, which means it is more than point, 0.5. So we are falling in this category, and less than 1.5. So we are falling in this category. So we have to take the coefficient corresponding to 0 degree and 90 degree again. So these are the wind angle in 0 degree and 90 degree, but that which coefficient we have to take, that will be based on the slope of the roof. How much is the slope of the roof? So in our case, the slope of the roof is 14 degree. Okay, so 14 degree, so it will fall between 10 degree and 20 degree. So you can linearly interpolate between these two coefficients for E and F and EF and GH phase, and for 90 degree EG and FH phase. So we can interpolate between these force coefficient to get the actual coefficient for 14 degree. So we have already interpolated here. So for E and Fs, so what is E and Fs? So our roof is somewhat like this, right? It will be it will have slope on this direction and this direction. So this portion is EF and this portion is GH. The slope will be like this. Okay, so this hatch pattern or hatch indicates that this is a local force coefficient which is acting on the roof, and this is the normal pressure coefficients which are acting on the roof. So these local force coefficients are calculated for a particular length or width. So this is the area where the local force coefficient or local pressure is more as compared to the inside area. So that portion will be defined as y is equal to h or 0.15 times width. So whichever is lesser. So this y will be calculated as per h. H is the height of the building, or 0.15 times the width of the structure. So in our case, it is coming. So h is 9 meter and 0.15 of width is 1.8 meters. So whichever is less, that will be our area or width for the application of local force coefficient. So this y will be the y is at 1.8 meter distance from uh, end. So So this 1.8 meter, this portion will have a local force coefficient. Remaining portion will have a normal force coefficient. Again, at ridge level, we have this local force coefficient. So from this end to this width, 1.8 meter width, will have some local force coefficient, and beyond that, again, normal force coefficient. So the code has given the values for that local force coefficient is based on this diagram. So once we calculate the force coefficients for 10, 14 degree by interpolating the values between 10 and 20, similarly we have to calculate for this local force coefficient also. So here we can see for 10 to 20 degree there is no variation, so we can consider 2. So this hatch pattern, it is 45-degree hatch in reverse direction. So that is acting somewhere here. Okay. So this portion is for that force coefficient of 2. Then here we have pattern like this. So for this portion, for the top portion, we have this pattern. For this vertical portion, pattern is in back forward slash. So based on this, we got these values for different patterns, and those values we have added here. Okay. So local force coefficient, it is minus 1.1 for this area, ridge type area, or area near to the ridge. 1.7 for this top portion or end of the truss. Then 45-degree hash 1.5 or 1.7. This is for the side wall areas, and 1.5. This is for the middle portion of the truss. This E and F, G and H phase will remain as it is, and it will have the force coefficient of 0.94, minus 0.56. EG is when wind is acting in 90 degree, minus 0.8, and FH is minus 0.6. For roof, the wind load is acting always away from the roof, so it is creating suction in the, or it is not creating suction, but it is creating some tension force in the roof, or it is pushing the roof away from the structure. So it is, the force is always negative. So again, we have to combine this with CPE and CPI, that is external pressure coefficient and internal pressure coefficient. So for first 0 degree, so for first 0 degree, we have local force coefficient of 1.7. We have grid 2 and 6. So just show you the grids. So this is a detailed sketch. We have grid 1, 2, 3, 4, 5, 6. So if we consider grid 6 and grid 2, it will be a similar. So we have force coefficient of 1.7 for grid 2 and 6. Grid 1 and 7 will have the same pressure coefficient. That is again 1.7. And grid 4, 5, and 3, 3, 4, 5. These three grids will have the same pressure coefficient. So for grid 2 and 6, 2 and 6, we have force coefficient of 1.7 local force coefficient, and for EF portion, it is, for portion E, it is 0.94. Then again at the ridge level, at this portion, the local force coefficient is 1.1, and beyond that for GH, it is 0.56. So for remaining portion, it is 0.56. Internal pressure coefficient is 0.2. This is same what we have calculated based on the percentage of opening present in the structure. That is based on the permeability. So we just need to do algebraic sum of these values. So 1.7 plus 0.2, so it will be 1.9. It will be acting at a distance of 1.8 meter. Then 0.94 plus 0.2, it is 1.14. So it will be acting on the remaining surface of the truss. Similarly, 1.1 plus 0.2, it will be acting as 1.3 as a local force coefficient for a width of 1.8 meter. And then 0.56 plus 0.2, it is 0.76. That is for the remaining portion of the truss. So these loads we are applying directly on the rafter instead of modeling the purlin and creating multiple beams. It is advisable to apply load on the rafter itself. So whatever load will be there, it will be applied based on the contributory width between the two rafters. So since we are considering grid 2 and 6, for grid 2 and 6, so this is grid 6. So for grid 6, the contributory width will be 5 meter, right? Half of this, half of this. So total will be the 5 meter. Similarly, for grid 2, it will be a 5 meter. So the load will be this force coefficient 1.9. This 0.706 is our wind intensity or wind pressure into 5 meter. This is contributory width. So 6.71 will be the local force acting on the rafter at 1.8 meter. Then we have 1.144 as a normal force coefficient. Again, wind pressure intensity into contributory 4.02. So similarly, we have worked out for the remaining width of the truss, and we have just applied these loads on the rafter. Now for grid 1 and 7, similarly, so grid 1 falling here and 7 here. So for first half of the truss, we have all as a local force coefficient, that is 1.7. So we have force coefficient of 1.7 plus zero point 0.2 is our internal pressure coefficient. So total will be 1.9 and total force acting is 3.35. Similarly, on other side, we have reach, for which we have the local force coefficient of 1.1, 1.1 and zero point 0.2. So 1.3, which will be multiplied with the wind pressure, and contributed will get the load on the member as 2.29 kilonewton per meter. And for remaining portion, it is 2.6. So similarly, for 3, 4, 5 grade, we have work out the loadings. Any doubt in this?
सर वो 5 कहाँ से लिए? ग्रेड 1 2 के लिए आप जो 6 और 4 6 एंड 2 के लिए आप मल्टीप्लाई किए 1.9 इंटू प्रेशर इंटू 5 लिखे हुए हैं, वो कहाँ से लिए?
5 is the contributory width और
सर सर इसमें मैं पढ़ रहा था आपका वीडियो रिकॉर्डिंग, तो मुझे समझ में नहीं आता वीडियो।
ये 5 जो है,
अच्छा, ये ग्रिड का डिस्टेंस लिए सर?
हाँ, ग्रिड का the distance between the grid. So when the wind will consider contributory width for this truss, it will be half of this, right? So this much of portion will be covered by this grid. So 2.5 meter on this side, 2.5 meter on this side. So this will be the total 5 meter.
ओके
So
सर।
that 5 meter we have to multiply.
तो ये सारे ग्रिड पर इसी तरह सारा डिस्टेंस निकलेगा सर?
Yes, it will be based on the contributory width. So when we are considering grid 7 and 1, it will be a 2.5, not 5. For 1 and 7, it will be 2.5, but the rest of the grid will be a 5 meter. Clear?
ओके सर। सर वो H/W करके वो कैसे निकालते हैं? विंड वाट स्टीव वाट वाला वो?
This H/W.
जैसे इसमें दिक्कत हो रही थी।
So this is the height of truss, right? Our structure height is 9 meter, width is 12 meter. So it is a ratio of 9 by 12. We are getting 0.75. This is the just ratio of height to width.
ओके।
Similarly, length to width ratio is there. So length is 30 meter, width is 12 meter. So 2.5 is our ratio.
सर ये थीटा बराबर 40 डिग्री, ये कैसा है?
Yeah, we have calculated based on the truss diagram. Our truss it is based on the total height of the truss and width. So it is calculated here. Slope of the roof is rise to length, that is 1.5 by 6. So what is this 1.5? This will be distance of this ridge from the horizontal flat level. So if you consider somewhat like this, so this height will be 1.5 and this width will be 6 meter. So tan of this, you will get the angle or slope of the roof. Clear?
Clear, sir.
So for first case, CPE plus CPI, when the wind is acting in 0 degree, we have worked out the load on the roof for all the grids. Similarly, for case 2, when CPE minus CPI, but wind is acting in 0 direction. During that time, we have to work out the load. Similarly, that will be worked out. All coefficients will be same except the internal pressure coefficient is acting away from the roof when we are considering the minus CPI. So again, we just have to find net force coefficient, and based on that, we have to calculate the loads by considering the contributor width and design wind pressure. So for this case also, we have worked out wind load on all the grids. It is written here, that is 5.29, 2.61, 3.18, 1.27, similar what we did for the plus CPI case. So first calculation is clear to all. Second one, second, third, and fourth are the same based on these cases. Any doubt here? And then third case we have to prepare is CPE plus CPI when the wind is acting in 90 degree.
सर तो ये जब हम सॉफ्टवेयर में लोड अप्लाई करेंगे विंड का, तो ये सारे पर अलग अलग कैलकुलेशन करके निकालना पड़ेगा।
ये तो हम मैन्युअली कर लिए ना अभी यहाँ पे कैलकुलेशन, तो यही
अच्छा।
लोड अप्लाई करना है हमको। ये आपको सॉफ्टवेयर में आपको जो क्लोज स्ट्रक्चर का है विंड, वो आपको मैन्युअली वर्कआउट करना पड़ेगा। सॉफ्टवेयर से लगाना है तो थोड़ा एटलीस्ट आप इसका तो लगा सकते हो, वो रूफ का या सॉरी वॉल का, लेकिन रूफ का आपको मैन्युअली वर्कआउट करके ही कम जो एक्चुअल वैल्यू है वो लगाना पड़ेगा।
तो सर थोड़ा केस में थोड़ा सा प्रॉब्लम हो रही थी,
इसमें
ऊपर वाली केस में आप 0 डिग्री पर 4 डायरेक्शन 4 डायरेक्शन दिखाए थे, फिर वो +-2 करिए किए थे। हाँ ये सर, ये हाँ यहाँ
इसमें
हाँ।
तो दिस इज योर विंडवर्ड डायरेक्शन, ये आपका विंडवर्ड डायरेक्शन है।
यस सर।
विंड अभी 0 डिग्री में एक्ट हो रहा है, तो 0 डिग्री में मीन्स हॉरिजॉन्टल एक्ट हो रहा है, तो उस वक्त आपका कोएफिशिएंट क्या है, ए विल बी द योर विंडवर्ड फेस, सो ऑन दैट इट इज 0.7, ये 0.7, बी इज -0.3, बी फेस ये है तो वो -0.3 है, सी -0.7 और डी -0.7, तो सी और डी -0.7 आ रहा है। अभी इसमें हम प्लस करेंगे इंटरनल प्रेशर कोएफिशिएंट।
ओके सर।
Because of opening there will be some internal pressure coefficient, so that will be added to this value 0.7 minus 0.2. It is acting opposite direction to this, so it will be a -0.2, so net coefficient will be 0.5. Similarly 0.3 minus 0.2 minus 0.3 minus 0.2, it will be a -0.5.
सर यहाँ फर्स्ट में पॉजिटिव +-0.2 होता था, फर्स्ट केस में पॉजिटिव लेंगे या नेगेटिव?
Which one?
सर केस 1 में जैसे 0.2 आप लिखे वहां पर, तो सर वो +-2 होता है ना?
ये दो केसेस आता है, एक CPI प्लस और CPI माइनस।
यस सर।
CPI प्लस मींस when plus means acting on the wall.
यस सर।
Okay. Or minus means acting away from the wall.
यस सर।
So we have considered plus, so it is acting on the wall, right?
यस सर।
तो ये एक्टिंग ऑन द वॉल हो गया. सो वी हैव टू कैलकुलेट द नेट प्रेशर कोएफिशिएंट बेस्ड ऑन दिस डायरेक्शन ऑफ द फोर्सेस और डायरेक्शन ऑफ द कोएफिशिएंट. तो यहाँ पे हमने नेट वैल्यूज निकाल लिया. 0.7 माइनस 0.2 0.5 आ गया यहाँ पे. 0.3 प्लस 0.2 ये दोनों सेम डायरेक्शन में एक्ट हो रहे. तो नेट आ गया 0.5. अभी 0.7 प्लस 0.2 तो ये हो गया 0.9. अगेन 0.7 प्लस 0.2 ये अगेन 0.9.
सर तो इसके मतलब इसमें कर रहा है केस 1 में सर ए पर एक्टिंग अवे फ्रॉम द वॉल 0 डिग्री कर रहा है उस पर एक्ट, तो वहां पर हम लोग माइनस लिए हैं. अगर ऑन द वॉल
दो केसेस बनाना है हमको कभी भी. एक तो कॉम्प्रेशन क्रिएट करेगा, एक सक्शन क्रिएट करेगा. ये अगर फोर्स वॉल पे लग रहा है तो ये कॉम्प्रेशन क्रिएट करेगा. और जब ये वॉल से दूर आ रहा है मतलब वो खींच रहा है अंदर, प्रेशर इतना है कि वो आपके वॉल को खींच रहा है अंदर, सो दैट विल बी ए सक्शन. बराबर समझ में आ रहे हैं?
यस सर.
कुछ डाउट होगा तो पूछो. ये दो केस हमको ऑलवेज बनाना ही है, प्लस और माइनस का दोनों डायरेक्शन के लिए. 0 डिग्री और 90 डिग्री फॉर बोथ द डायरेक्शन यू हैव टू प्रिपेयर बोथ दिस केसेस.
यस सर.
तो ये आपका फ्लैट सरफेस के लिए होगा और रूफ के लिए भी होगा. और ये इंटरनल प्रेशर कब आएगा? जब आपका स्ट्रक्चर क्लोज रहेगा तब भी आएगा. अगर आपका स्ट्रक्चर ओपन है तो ये केसेस नहीं आएगा. बराबर. सिर्फ आपका एक्सटर्नल प्रेशर कोएफिशिएंट आएगा, इंटरनल 0 रहेगा अगर स्ट्रक्चर ओपन है तो.
यस सर.
तो केस 2 जो है वो हमारा Cp minus Cpi when wind is acting 0 degree. Again we have worked out the local force coefficient and normal force coefficient on the roof surface, and we have arrived at the values of the loads for each grade. Then again third case will be same for 90 degree. Again Cp plus Cpi again for local force coefficient and normal force coefficient, and we will get the values. Then for the negative or the fourth case is Cp minus Cpi when wind is acting in 90 degree. So it is just a mathematical procedure. Once we get these coefficients by considering the so this is the important one to get the coefficient, and just to apply that coefficient at particular locations to get the values or to get the loads. Okay. So this will complete the wind load calculation for the truss. Now what we will do, we will start with the STAAD model. For this truss, we will apply all the loads. We will try to design the members, and we'll see how we can go with these defining STAAD parameters, then applying the load, how to design the sections. If the sections are failing, how we can pass them. Okay. Just this one. Sorry. So what is the geometry? So the spacing between the column is 5 meter and transverse spacing is 6 meter. We have these two columns at the end. Does anyone have why we have these two columns? I think we have discussed. Not. What is the purpose of those two columns? Anyone? What happens if we don't provide any column over there? Our structure is how it is. It is open or closed.
Open, sir.
Our structure is closed,
It is closed.
right?
On
For
table one.
it is closed. That's why we are calculating this internal and external pressure coefficient, right? Otherwise, we would have applied directly as a open structure wind. So, what is the purpose of this column, and why we have not provided here? And what if we don't provide here also? Anyone?
सो वो जो क्लैडिंग या जो कवरिंग मटेरियल है ताकि उसको ब्रेक कर सके बीच से, मतलब वरना वो लार्ज हो जाएगा.
Correct. So we need this column. This is cable and column, and when we are running cladding runner, we cannot span it for the 12 meter, right? So in order to cut that cladding runner, or in order to shorten the span of cladding runner, we have to consider one column here, so that we can place cladding runner here, and then we can support the sheeting over here. Otherwise 12 meter length will be huge and it will buckle in minor direction. Okay, so now okay, I'll just take this column to meter. So this is our main structure. I'm just going to assign some columns exercise. So just tell me what should be the orientation of columns. Just submit here. So which orientation is correct and which orientation is wrong? So out of these three columns, which one is correct, which one is wrong? Or what
Middle one should rotate.
middle one should rotate, and what about these two ends? Okay, why we should rotate the middle one? Why do we need to rotate that one? And what will happen?
Opening of column.
Buckling, but it can happen on the end column also.
Yes, sir.
What is the other reason? Is there any tie possible on the for that column? Is it possible to tie that column in other direction? So can I tie this column on this side? I can tie on this side, right? I
Yes,
can
sir.
tie on this side, right? But can I tie on this side
No, sir.
for this column? No. So that's why we have to rotate this column like this. So in order to have the major axis in the direction where we do not have a tie, that's why we have to put column like this. Okay, we can tie in this direction, but we cannot tie in this direction because our column is at other column is at 30 meter length. That's why we have to rotate this column in this direction. This direction Why? And then why we need this column in this direction? We can also rotate this one. We have tie on the top also. The basic reason of keeping this column is this, that we have a rafter here, right, at top. And we are just providing a movement connection to this rafter and beam, or rafter and column. Always movement connection will be in the flange. It will be never in on the web side. The movement connection, if it is there, it should be always on the flange side, not on the web side. So that's why this orientation is correct. This orientation we have to change. So we'll just assign a beta angle by 90 degree, and we'll apply it to both the columns. Okay. So now the orientation is changed. So do you know the which is major axis and minor axis for the member? So if my section is like this is one axis, this is other axis. If I say this Z, this is Y. Which is major axis? Y or Z?
Z.
Which one?
Z.
It's Z. Okay. So Z is the major axis because we have the maximum moment of inertia or major moment of inertia in about Z axis. About Y axis we have less moment of inertia. So when we are orienting like this, right? So our major moment of inertia will be about Z axis. This is Z axis of the section, and our major moment of inertia is about this axis. So that's why when we calculate the slenderness is calculated by I by A, right? I by A, square root of I by A. Based on that, we calculate the slenderness. So once we place this axis in this direction, it will not have any tie for its complete length of the member. So in order to have the more less slenderness in this direction, we also rotate this column so that its compression capacity will not get reduced. So this is about the column orientation. Now we will just tie all these columns in longitudinal directions. We have connected all these members. Similarly, now this is the minor direction, right? This is minor direction for the column. So we cannot put column with a complete height of 9 meter when we have minor axis in this direction. So in order to break its length, we have to provide tie members. So we'll just create another tie in between. We'll create first node. So we have created node and we have just divided the column into two members. And we'll add simply beam. So now beams are added. We'll assign some properties. And select the section size of MB300. And we'll just add a rafter also. So we have a rafter at 1.5 meters from this distance.
सर थोड़ा धीरे कीजिए सर, दिख नहीं रहा।
नहीं रहा है?
हाँ, वो फास्ट कर देने तो पता नहीं चल रहा कहाँ जा रहे हैं आप, फिर हम
अच्छा,
लोग को। हाँ
मैं बताता हूँ आपको क्या क्या है। So अभी we have just created a tie members for the columns so that its length in minor direction will get break and its slenderness will increase. Slenderness will be decreased. Then we have just created a rafter member at the top, so it will look like this. So this is a rafter member. These are the gable end columns at two ends. If we just select one frame in between, it will look like this. Okay, so we'll assign property to this member as well. So I'm just providing any size at the moment. So we have assigned the sizes for all the members. Now, so we have just provided this tie member here, but will it reduce the effective length in minor direction, or do we need to add something else to reduce the effective length? Any idea how we can reduce that?
Bracing also we can add.
Yes, we can add bracing. And if we don't add bracing, what will happen? Will it be the same length or will it be reduced by just providing these beams?
If we add bracing, then the effective length will be reduced.
Mhm. Okay, so just add bracing here. I'll add somewhere here. So where should I add bracing? On this bay, or somewhere in the middle? Which is the best location for the bracing? End bay or central base? What will happen if I add a bracing at the end base? Is it a good idea to add bracing on the ends? Whenever there will be a temperature or there, because of temperature, there will be an expansion of the structure, right? Expansion or contraction of the structure, right? So when we add a bracing here at end bay, it means that we are locking the structure from expanding and contracting, right? Once bracing is added, then structure will be not allowed to expand or contract when we add it at the end. But when we add somewhere in the middle, then sorry, when we add somewhere in the middle, then the structure will be free on both the sides to expand and contract. So that because of that, there will be less internal forces or temperature forces, right? So it is always keep in mind, never add bracing at the end of the structure. Let the structure expand in any direction so that temperature stresses will be less and structure will be economical. If you don't allow that structure to expand or contract, there will be a huge internal stresses due to temperature, and that will cause the higher section size. So we'll add bracing somewhere in the middle. So just add a section size to it. So for this bracing, now we'll assign as a member truss. So it will carry only the axial load. It should not carry any bending moment in it. So once we assign it as a truss, it will behave as a axially loaded member only, and it will carry either compression or tension. So now, since this bracing is added, so should we keep this as a movement connection or should we release them? All this tie member. How the force will get transferred? So there are two frames, right? One is brace frame and another is movement frame. So this is one frame and this is other frame. So this is with the bracing. This is with the movement connection. So when we have force here in both the cases, how will be the bending moment diagram for this and this? Will there be any bending moment in this beam? Will there be any end moment for these beams? For this case one?
No.
No. Okay, so this will be my pin support. This will be the fix. So if there is no movement, then how it will be stable? The horizontal load has to be registered by someone, right? So there will be a bending moment. It will be like somewhat like this. This will be pin. So there will be an end moment in the beam, right? Now when we provide bracing, what will happen? So when we provide a bracing, that horizontal load will pass through this member as axial force, and through this bracing as axial force, right? So it will be component like this. This component will be taken care by this beam. This component will be by this column. In that case, there will be a no end moment, and we can simply release this member at the both ends. There will be a no moment. So let's check with one simple example. Whenever we add bracing to any frame in that direction, then all the members should be released. So we have this frame. For one thing, we'll add bracing. Just analyze it. Okay, so we'll see the movement for these two figures. So when we have a horizontal load, we have end moment in the beam, and when there is a bracing, even though the load is acting horizontally, there will be a no movement in this beam. So we can release this member and we can design this as a shear connection, whereas we have to design this joint as a moment connection. So it is always good practice to have a bracing, and as much as possible we have to provide the shear connection. Okay, so in this case, so all this member will be now released. Clear? Understood this?
Yes, sir.
Why we are releasing these members? So all these members are released, and all these members will be a shear connection. We have applied a truss member for these bracings, so it will carry only axial load. Whatever load due to the horizontal forces like wind, etc., that will be carried through this bracing to the base plate as a axial force. Okay. So similar bracing will put on the other side of the truss, and then we will release the tie member on this side as well. Okay. So we have released all the members. Let's find support condition. So now we have added bracing on either side and movement frame on either side. So what will be the connection for the base? Will it be a pin connection, fixed connection, or fixed butt connection, or support type? What should be the support type here?
Pin connection.
Okay, pin connection for these members. And what about this for gable end column, central column? Will it be pin or fixed butt? It should be fixed butt, right? Because for this column we have moment connection at top and bracing in this direction, so this can be considered as a pin connection. For this column we have moment connection in this direction, but or we can add a bracing in this direction by providing beam here, but in this direction it is uh, it is unsupported or there is no tie beam, so it should be fixed butt connection. So we'll just add first pin connection, then another fixed butt. So which will be the release? I need fixity in this direction. So I need mx to be fixed and release mz and my. Okay. So this will be added. So it will create a fixity for the in that direction, and these two all the forces will be all the supports will be released. Okay. So this is the fix. So about this axis, it will be a fixed, and other two axes will be fixed. Okay. So this support is clear.
So can you please explain this once again?
Which one? This support allocation.
Yeah, this one, fixing the X MX and releasing MY due to which what reasons, sir? Explain once again, please.
For this column, we do not have any bracing or any movement connection in this direction, right? We have column to column distance is 30 meter. Even though we will have some tie member here at 5-meter interval, but those will be a shear connection beams or simple connection. It will not be a movement connection. So that's why we need somewhere fixity, either at the top or a bottom, right? In this case, if I consider this frame, in this case I have fixity here. I have considered movement connection at the top, and in other direction we have bracing. So whatever horizontal force is there, that will be, when the force is in x direction, that will be taken care by this movement connection, and in z direction it will be taken care by the bracings. But in case of this column, when we consider gable end column, in this case, this x direction will be taken care by this movement connection at these two ends. But when the load is acting in z direction, the load will be acting on this column also. But this column is not having any tie in the z direction, right? We do not have any beam or anything. In order to fix member, we need to assign fixity at the bottom, right? So that's why we have considered the fixed butt type connection. Fixed butt means our connection or our support is fixed, but what we want to release, my and mz, but mx should be fixed. That is called a fixed butt connection, correct? We are saying that my connection is fixed, but I want to release my and mz. So that's why we have released my and mz, and we have kept mx as a fixed.
Okay, sir. Practically, how we can do that in the site? How
Inside,
we can?
you have to arrange the bolt arrangement. You have to prepare such that the bolt will take some fixity or some movement. So it depends on the arrangement of the bolts. So how
Okay.
do you know how we can achieve the pin and fix connection in steel structure? So we'll okay. So let's discuss that later. While designing of the base plate, we'll see what is fixed type of connection and what is pin type connection. We'll just add a beam here. So these all members will be released members. So we cannot provide a movement connection for these beams because these beams are connecting in the web of the rafter, right? In the web, we never do the movement connection. So this is the basic geometry. Now we have to add some bracing for this rafter. In order to break its length, we have to add some bracing. So we'll add a bracing in this way only. So I'll just create a nodes. We'll just create some members. So again, this member will be released. Okay, this is one set of bracing we have added. Then if required, if this rafter is failing due to the movement or due to the actual load, then we can just add a member here so that its effective length will get reduced. Similar to the elevation, what we did here, we have just added a bracing and we have just added a tie member so that the length of all the columns got divided into half and its slenderness is also got reduced. I'll just assign some member properties. For time being, we'll consider this section size. Based on detail analysis, we can change the section size as required. We have assigned all the section sizes to members. So we'll add some same member size and bracing on this side also. And we'll add a bracing here on one bay only. So again, bracing is added. This member can be released. We have to assign this member as a member truss so that they can carry only the axial load. So this time member I am assigning 300 and again bracing of 100 by 8. So same bracing will be continued on the other side of the structure. Okay. We have added bracing here, so all the geometry is almost done. Then we have to add the roof load, then wind load, and roof wind load. Then we'll just design the truss. We'll see how the section sizes are required. So up to this, any doubt about anything like orientation of column? It's why we are consider that orientation, support, releases, bracing locations.
Sir, if we have any opening for roller shutters and doors, then we can adjust the height of this type member according to that.
Yes, you can adjust the
Different,
time member.
yeah.
Yeah, you can adjust the time member. Normally, the height is around 3 meter or something, so it is already at 4.5 meters. So you can just, if required, you can just elevate this member as per your shutter height. Then you can just provide some channels on this side so that a shutter can be fixed on that. This is just like it depends on where or how you can provide the or how you can reduce the slenderness of the member. There are many ways, like you can add some beams here, 2 or 3 beams you can add. If section size is if this section size is getting much bigger, then you can add somewhere here another section, or this bracing size if it is failing in slenderness, then you can add some more member here and we can shorten the bracing. So there are also multiple ways. It depends on how how you can optimize the structure. So any doubt up to this? So in next session we'll just apply all the loads from roof to the wall load, again load, self weight. We'll create some cases and then we'll design the
Excuse me, sir.
harmony.
So the arrangement of bracing is our choice, or is it there? Some thumb rule is there?
No, it's actually if it is a warehouse or any shed, it depends on us or the architectural. Where are the openings or where they need some forklift movement? So based on that, they can provide us the tentative location of the bracings. But in other structures like process structure or technological structure, where other multiple disciplines are involved like piping, mechanical, electrical. So in that case, we have to discuss with them for the possible locations of the bracing, and at that location we have to put the bracing. But in case of warehouse, we just need to check where the access is there, like for the forklift or any opening is there or any crane movement is there. So based on that, we can decide the bracing location.
ओके
सर
Yeah.
सर आपसे क्योंकि थोड़ा फास्ट जा रहे हैं सर, कर्सर में दिक्कत हो रही है मुझे। कोई सर अगर सर का कुछ प्रेशर है तो आप मैं बात करूंगा, लेकिन नहीं सर वो मुझे
प्रेशर ऐसा कुछ नहीं है, ये आपको ही हो रहा है या सबको हो रहा है कि दिख नहीं
सर
रहा?
मुझे मैं सर अपना जानता हूँ, मैं किसी का और को नहीं बता सकता कि मुझे दिक्कत होगी।
नहीं, जो कर्सर नहीं दिख रहा है जो बोल रहे हैं ना आप,
नहीं दिख नहीं रहा, मतलब आप पढ़ा रहे सही, मैं नहीं बोला, देखिए आप कर्सर को ले जा रहे हो कहीं, कभी किसी चीज पर, कभी किसी प्रॉपर्टी पर, तो सर वो फास्ट जा रही है। थोड़ा सा स्लो हो जाता है तो हम लोग भी पता चलता है कि कहाँ पर क्या चीज है, तो इससे ज्यादा बेनिफिट होता है सर।
That is what I am asking. That lag is for everyone or?
Sir, actually he's talking, sir.
हाँ,
एक्चुअली सर हाँ आई विल स्पीक सर। एक्चुअली हमारा स्टैड प्रो है ना, वो भी कंप्लीट नहीं हुआ सर अभी, मतलब स्टार्टिंग की 3-4 क्लास हुई हैं, तो आप क्या थोड़ा कमांड जल्दी बता रहे ना, इस चक्कर में वो ये चीज बोल रहे हैं कि थोड़ा हमें कैच करने में थोड़ा टाइम लग रहा है, तो इसलिए वो बोल रहे थे कि थोड़ा सा आप एक बार प्रीव्यू दे देंगे तो वो इजी हो जाएगा हमारे लिए।
चलेगा। आई थॉट कि लैग हो रहा है क्या, मैं बोल रहा हूँ और बाद में आपको स्क्रीन दिख रहा है क्या? आई थॉट
नहीं लैग नहीं हो रहा सर, वो समीर जी ने जो बात बोली वो सही बोल रहे हैं, क्योंकि सर वो क्योंकि सर मैं आपको मैं जब स्टडी करूंगा तो इसको मुझे पढ़ने के लिए 4 घंटा लग जाएगा, ये चीज मुझे पता है, क्योंकि मैं एक चीज बारीकी से देखता हूँ फिर जाके प्रैक्टिस करता हूँ सर, तो इसलिए आपसे रिक्वेस्ट कर रहा हूँ।
ओके, ठीक है। तो ये एक मॉडलिंग स्लो करेंगे। अभी तक कुछ डाउट है क्या? तो मैं फिर से एक्सप्लेन करता हूँ आपको।
अभी सर तो मैं इसको पढ़ लूंगा, उसके बाद ही मैं डाउट पूछता हूँ।
देखिए यहाँ पे दिस इज द प्रॉपर्टी पेज from where we can select the properties. So if I click here, then I will get the properties. This is section database where sections for all the codes, like or all the countries like American, European, British, all sections are available here. American, Australian, Brazilian, British, Canadian, Chinese, Indian, all sections are available here. So we can select section size from here. We can just add it in our selection category. Once we add it here, it will come here automatically, and then after coming here you can select this section size. First select this beam, select section size, select beam to which you have to assign, then assign to selected beam. Okay, you can assign to view also when you have all the members.
आप अभी बता रहे सर, इसी तरह बाकी में बताइए सर, मुझे हड़बड़ी नहीं है सर, मैं जॉब छोड़ चुका है इसके लिए, 50 का जॉब छोड़ा हूँ मैं स्टैड प्रो के पूरा कोर्स लेने के सर, डिजाइनिंग में जाने के लिए, इसलिए आपसे रिक्वेस्ट कर रहा हूँ मैं।
ठीक है, स्लो में सिखा दूंगा आपको।
हाँ कोई इशू नहीं है,
ऐड के लिए
टाइम लगता है उससे इशू नहीं है सर, मैं दिसंबर भर बैठ सकता हूँ, कोई इशू नहीं है मेरे लिए।
नहीं, टाइम का इशू नहीं है। आई थॉट कि आपका स्टैड वगैरह हो गया रहेगा, इसलिए मैं आपको बता रहा था।
नहीं सर नहीं, जैसे ये अभी लगता है आई थिंक 5th या 6th सेशन होगा, इससे पहले 2 सेशन 3 सेशन पीपीटी का हुआ था और 2-3 सेशन इंट्रोडक्शन का साइड हुआ था।
टोटल 4 मतलब अभी बेसिक्स के हुए हैं सर, मतलब स्टैड प्रो में जो बेसिक कमांड्स हैं उनके मतलब हो गए सर, जैसे कॉलम बीम नोट्स वगैरह ट्रांसलेट करना या फिर कॉपी पेस्ट या मिरर, इस टाइप की कमांड्स हो गई हैं, और जो बेसिक पीपीटी में जो डिजाइन है मेंबर्स का वो बता दिया है। तो अभी सर इतना अभी कंप्लीट हुआ था हमारा, तो इसलिए वो सही बोल रहे हैं कि हमें थोड़ा कैच करने में टाइम लग रहा है।
ठीक है, तो हम स्लो जाएंगे। स्टैड मॉडलिंग हम पूरा अभी इतना, अगर आपको इसमें आप देखिए, अभी कल तो सेशन नहीं रहेगा। आप जो स्टैड का हमने देखा है ना, पहले तो आई थिंक फर्स्ट हाफ एन आवर वाज थ्योरी ओनली, सो जो नेक्स्ट हाफ एन आवर का है तो उसमें हमने स्टैड का मॉडलिंग किया है, तो वो एक बार देख लीजिए। आपको कुछ डाउट होगा तो हम परसों सेशन रहेगा, उसमें फिर से स्क्रैच से हम चाहिए तो मॉडलिंग स्टार्ट करेंगे, नो इशू।
नहीं सर वो थोड़ा बहुत तो सर आ गया था, वो कोई दिक्कत नहीं, अगर डाउट लगेगी तो वो चीज पूछ लेंगे सर, वो
यस सर।
चलेगा
बाद में।
चलेगा।
अगर समझ आ गया तो कोई प्रॉब्लम नहीं, आप आगे से यहीं से कंटिन्यू कर देना, लोड केसेस और डिजाइन।
ठीक है, चलेगा चलेगा। तो अभी ये तो हमारा बेसिक फ्रेमिंग हो गया। तो अभी हम यहाँ पे जाएंगे और एक एक लोड कैसे ऐड करते हैं, यहाँ पे कौन सा डेड लोड, लाइव लोड, विंड लोड, सबको ऐड करके हम एक एक लोड अप्लाई करेंगे यहाँ पे। ठीक
ओके सर।
यस सर, वो लोड तो बता दिए थे सर ने हमें ऐड करने, तो
हाँ
उसमें देखते हैं। बाकी सर आप बताओगे तब एक बार पता चल जाएगा और क्लियर हो जाएगा।
हाँ। नहीं, इसमें स्टैट में बहुत है कि आपको मेनली ये लोड एप्लीकेशन और ये ज्यादा डिफिकल्ट नहीं है। सबसे इम्पोर्टेंट स्टैट में होता है कि आपका पैरामीटर असाइन करना, कि आपका मेंबर का LY क्या है, LZ क्या है, उसका अनसपोर्टेड लेंथ क्या है। तो दैट इज द मोस्ट इम्पोर्टेंट थिंग इन स्टैट। तो उस पे ही पूरा सेक्शन का डिजाइन होता है कि आप मेंबर का लेंथ क्या कंसीडर कर रहे हो, बिकॉज once you create a node, STAD will not understand whether it is one member or two member. So if this node is created here, अगर यहाँ पे ये नोड है तो ये STAD को पता नहीं चलेगा कि ये एक ही मेंबर है, ये दो मेंबर कंसिडर करेगा इसको। तो इसको कंप्लीट लेंथ कैसे असाइन करना है, कौन सा लेंथ असाइन करने से ये कंप्लीट अज्यूम होगा, तो ये हम डिटेल में देखेंगे। तब आपको थोड़ा पता चलेगा STAD के बारे में। बाकी STAD कुछ डिफिकल्ट नहीं है इतना।
ओके सर।
ओके, सो आप एक बार स्टडी करो, अगर नहीं समझ में आता है जो अभी आज मॉडलिंग किया है तो हम फिर से करेंगे।
हाँ सर, मैं वो मुझे नहीं समझ में आएगा तो मैं पूछता हूँ सर, मैं
नहीं
शर्माता नहीं हूँ।
नहीं, चलेगा चलेगा। नहीं, उसमें शर्माना क्या है, आप अगर किसी चीज के लिए पे कर रहे हो तो
नहीं
उसमें पूछना ही
सर,
चाहिए।
एक्चुअली सर बात पे की नहीं है, बात है नॉलेज की। मुझे
नहीं,
नॉलेज ही
नॉलेज
नहीं, मुझे नॉलेज ही नहीं होगा, तब मैं वो चीज करके क्यों करूंगा।
वही
नहीं।
बराबर है। तो आप पूछो, जो कुछ भी डाउट रहेगा ना, जितना मेरे कैपेसिटी में रहेगा मैं हर एक चीज एक्सप्लेन करूंगा। नॉट ओनली अबाउट स्टील स्ट्रक्चर, आपको कंक्रीट का कुछ डाउट रहेगा, किसी भी चीज का रहेगा तो मैं आपको क्लियर करूंगा।
ओके सर।
ओके सर।
ओके ओके, चलो।